The most terrifying objects in the universe. Imagine traveling through space. Millions of light years away from Earth. There are no planets around you. No stars close enough to touch. Nothing unusual. Until you see something that should not exist. A darkness so complete that even light cannot escape it. You move closer, and suddenly, the stars behind it begin to bend. Space itself appears distorted. Your instruments begin to behave strangely, and ahead of you, there is no surface, no wall, no solid object, only a boundary, a point of no return. Cross it, and whatever happens next can never send a message back to the outside universe. This is a black hole, and perhaps the most terrifying thing about them is not what we know, it's what we don't. What is a black hole, despite the name? A black hole isn't actually a hole. It is an enormous concentration of matter compressed into an incredibly small region of space. Its gravity becomes so extreme that beyond a certain boundary, nothing can escape. Not a spaceship, not a particle, not even light. That boundary is called the event horizon. Think of it as a cosmic point of no return. From far away, you could watch an object approach it. But once that object crosses the event horizon, there is no way for information from inside to reach the outside observer. The black hole doesn't need to chase anything. It doesn't need to pull everything in from across the universe. You simply have to get too close. And once you cross the boundary, the rules of escape are over. Here's something strange. We photographed a black hole, but we can't actually see the black hole itself. Why? Because no light escapes from inside the event horizon. So what did scientists actually photograph? They photographed the environment around it. Superheated gas, dust, radiation, and matter moving at enormous speeds around the black hole. This material forms what scientists call an accretion disk, and this disk can become incredibly bright. Sometimes, the environment around a black hole can shine brighter than entire galaxies. The black hole itself remains dark, but the violence surrounding it gives it away. For decades, black holes existed mostly as predictions. Scientists knew the mathematics. They observed stars moving around invisible objects. They detected powerful radiation. They saw matter apparently disappearing. But then, in 2019, humanity saw something extraordinary. For the first time, an international team using the Event Horizon Telescope revealed an image of a black hole's shadow. The target was M87 star, a supermassive black hole at the center of the galaxy Messier 87. It was approximately 55 million light years away, and its mass was about 6.5 billion times that of our sun. The image looked almost deceptively simple. A bright ring, a dark center, but behind that image was an Earth-sized virtual telescope and years of observations. Humanity had finally seen the silhouette of one of the most extreme objects predicted by physics. The EHD collaboration released the first image of M87 in April 2019. The black hole is estimated at about 6.5 billion solar masses and roughly 55 million light years away. The monster at the center of our galaxy. And then, we look toward home, at the very center of our own galaxy. Something enormous has been hiding. Its name is Sagittarius A star. Astronomers had already discovered stars orbiting an invisible object at the center of the Milky Way. Those stars were moving around something extremely massive and extremely compact. Then in 2022, the Event Horizon Telescope produced an image of Sagittarius A star, the black hole at the center of our galaxy. Its mass is approximately 4 million times that of our sun, and yet, from Earth, it appears incredibly tiny in the sky. For million suns, compressed into an object whose shadow can be studied from more than 25,000 light years away. There's something deeply unsettling about that, because the most massive gravitational object in our neighborhood is sitting at the center of the galaxy, right now. But where do these monsters come from? Some black holes begin with stars. Very massive stars spend millions of years fighting a cosmic battle. Gravity tries to crush the star inward. Nuclear fusion pushes outward. For most of the star's life, These forces remain in balance, but eventually, the fuel runs out, the outward pressure weakens, gravity wins, the core collapses, and under the right conditions, the collapse creates a black hole. The star can explode, sending enormous amounts of material into space. But deep inside, something far darker remains, a region where matter has been compressed beyond anything we can reproduce on Earth. A stellar mass black hole, a remnant of a dead star. The most terrifying part, spaghettification. Now imagine you are falling toward one. At first, you might not notice anything unusual, but as you approach the black hole, gravity becomes dramatically stronger. And here's where things become terrifying. Gravity isn't exactly the same across your body. Your feet might be pulled more strongly than your head. The difference becomes enormous. You are stretched vertically while being compressed from the sides. Scientists call this spaghettification, an unsettlingly humorous name. For something that would be anything but humorous, your body would be stretched into a long stream of matter. And the closer you get, the more extreme the tidal forces become. Eventually, you would be destroyed. But there is an even stranger question. What would you actually experience with time? Black holes don't just distort space. They distort time. According to Einstein's theory of relativity, the stronger the gravitational field, the slower time passes relative to a distant observer. Imagine you are falling toward a black hole while your friend watches from far away. From your perspective, you continue falling, but to your distant friend, your movements appear increasingly slowed. The light coming from you becomes more and more stretched. You appear to fade and become harder to see. Eventually, you disappear from their view. But what happens from your perspective? That depends on the black hole and the details of the fall. And this is where our understanding becomes much more complicated. Because once you cross the event horizon, we cannot receive information from you. Whatever happens next remains hidden, the point where physics breaks. At the center of the classical picture of a black hole, there is something called a singularity, a region where our current equations predict extreme, even infinite, curvature and density. But here's the important part. Scientists don't actually know whether the physical universe contains a literal point of infinite density. The singularity may be telling us something else. It may be telling us. But black holes don't simply swallow. Some of them appear to launch enormous jets, powerful streams of particles, traveling outward at speeds approaching the speed of light. And these jets can extend far beyond the black hole itself. The supermassive black hole in M87, for example, produces a gigantic jet visible across thousands of light years. Think about that. A region from which light itself cannot escape can be connected to a structure stretching thousands of light years into space. The black hole isn't shooting matter from inside the event horizon. The exact processes happen in the extreme environment around the black hole. Magnetic fields, hot plasma, and rapidly moving matter all become part of this cosmic engine. That our current theories are incomplete. General relativity works incredibly well. Quantum mechanics works incredibly well. But inside the deepest regions of a black hole, we need a theory that can describe both. And we don't have that complete theory yet. So at the center of a black hole, there may be one of the biggest unanswered questions in modern physics. What actually happens to matter after it crosses the horizon? The biggest black holes. Stellar black holes are terrifying enough. But then, there are supermassive black holes, objects with millions, or even billions, of times the mass of our sun. They sit at the centers of many large galaxies, including ours, and some of them are so enormous that their event horizons could span distances comparable to the size of our solar system. The universe appears to have built gravitational monsters on scales that are almost impossible to imagine. But here's another mystery. How did some of these black holes become so massive? So early in cosmic history, we have ideas, but the complete story is still being investigated. What if one came near Earth? Now for the question everyone eventually asks. What if a black hole came close to Earth? Would it suddenly suck us in? Not necessarily. A black hole doesn't behave like a cosmic vacuum cleaner. From a distance, its gravity behaves according to the same basic rules as gravity from any other object with the same mass. If our sun were somehow replaced by a black hole with exactly the same mass, Earth would not suddenly be pulled into it. Our orbit would remain approximately the same, but there would be one enormous problem. There would be no sunlight, Earth would become dark, and the consequences would be catastrophic. So the real danger isn't some magical cosmic suction, it's gravity, combined with proximity. Get close enough, and the universe becomes a very different place. And this brings us to something extraordinary. The famous images of black holes are not photographs of the black hole itself. They are images of light, bent around an invisible object. The dark center is the shadow. The glowing ring is material and radiation around it. Gravity bends light, allowing us to see the silhouette of something that cannot emit light itself. And even today, scientists continue to refine these observations. In 2025 and 2026, new Event Horizon Telescope analyses have revealed more information about the changing magnetic environment and jet-producing regions around supermassive black holes. The picture is becoming clearer, but the deepest mystery is still hidden behind the horizon. Maybe the most frightening thing about black holes isn't that they can destroy stars. It isn't that they can bend light. It isn't even that they can trap light forever. It's this: we don't know what lies beyond the horizon. We have equations, we have observations, we have simulations. We have now seen the shadows of these objects. We have watched stars orbit them. We have detected their gravitational waves. We have observed matter disappearing from view. And yet, the deepest interior remains inaccessible. Perhaps one day, a new theory will tell us what happens there. Perhaps quantum gravity will reveal something we cannot yet imagine. Or perhaps black holes are hiding something fundamentally different from everything we currently understand. For now, there's only one boundary, one point of no return, the event horizon. And beyond it, the universe keeps its secret. Black holes remind us that the universe is far stranger than our imagination. We once believed they were only mathematical possibilities. Then, we found them. We watched their effects. We measured their gravity. And eventually, we saw their shadows. But the greatest mysteries are still waiting. Because every time we discover something new about the universe, we uncover an even deeper question. And perhaps that's the real reason we keep looking into the darkness. We begin with the story. Then we discover what is really behind it. This is the Crystal Mind,